take a vertical line such as this ruler here, and as I'm moving the graph or moving the ruler across the graph, I'm looking to see if it ever touches the graph at more than one place. Okay, if it does not, then it is a function. So if the vertical line does not touch the graph twice at the same time, then it is a function. Okay, if the graph touches it twice, and I'll show some examples here in a few minutes. Okay, but if it touches the graph twice, then that is something we would say is not a function.
Mr. Anderson,
Yeah,
I thought a function was like the equations that we were doing, like the fx equations.
they are. I mean, a function can be a graph, it can be an equation, it could be
Okay.
a whole bunch of things.
Okay.
Okay, so like the one yesterday on the practice test kind of looked like this. Okay, so again, if we took the vertical line and we moved it across, okay, the graph, okay, when you get to this point right here, the vertical line straight up and down, it's touching these two spots, right, at the same time. Okay, that's bad. So if it does touch the graph twice, then it is not a function. Okay, so taking a look at these 4 graphs. Okay, again, take a vertical line, could be a pencil, could be a pen, whatever you got on you. Is it touching the graph at more than one place? It is not. So that's a function. You look at the circle. Yeah, it's going to touch the graph at more than one place. Not a function. Here, it's never really touching the graph at more than one place, so we're good here. And then the sideways parabola, definitely not, because it's touching the graph at more than one place. All right, so if you're given a graph, asked to determine whether or not to function, you should be saying yes. It passes the vertical line test, or no, it does not pass the vertical line test. Okay, the other thing you could be given is a table or maybe a set of points. We'll go through what that has to look like. Okay, so what I wrote was each input has to have a unique output. Give you a second to copy that down. Okay, so what I mean by that is that each input has to have a unique output. So right here, we're fine because -3 gives us an output of 9, -2 is 8, -1 is 7, 0 to 6, 1 to 2, 2 to 4. Okay, none of these inputs repeat. Okay, so far it's fine. But if I added the same input like 2, okay, and I gave it a different output like 3, okay, this is bad. Okay, you can't have the same X value have different Y values. Okay, that is probably the easiest way to think of it. Okay, the same X value can't have different Y values. All right, so take a look at a couple examples here. Give you a minute or two to copy those down. Okay, so as we look at this first one, okay, x value of 1, and then we have a y value of 2. X value of 1, and then a y value of 3. 1 and 4, 1, 5, 1, 6. Okay, so this is really not good. Not a function, okay, because the input of 1 is going to give us a whole bunch of different outputs. Not what we want. Okay, here we have a whole bunch of different inputs that give us the same output. That's fine. Okay, because if they're all going to give us the value of 1, that's okay as long as the inputs are all different. Okay, it doesn't really matter what the outputs are. Okay, the third one, 1, 4, 1, 7, 2, 7, 3, negative 4. Okay, so on these two, we have the same input of 1, and it's giving us two different outputs, 4 and 7. It's not good. Okay, here all of our inputs are different. Okay, so there's no issues there. We're going to have different outputs. It doesn't really matter. Okay, but since all of our inputs are different, we don't have to worry about an output not repeating. So we're good there. So again, you have two choices. Okay, yes, because all inputs have unique outputs. Or no, because all inputs do not have unique outputs.